Yeah, we're rolling. This is our 1.4 combinations of functions, but we're not actually going to start with notes. We're going to start off on GeoGebra. We're going to start on GeoGebra, okay? Now, focus please. We're going to start with this one. What happens when you add up two functions? Somebody give me a guess for a point that's going to be on the function created when you add up these two. What do you think it means to add up the two functions? The intersection. So you're guessing, what does that intersection look like? 1, 5? 1, 5. Okay, that's one point we think is going to be an add. What else do you think is going to be an add? When you add up two functions, what do you think you're adding up? They're intercepts, so what are the two intercepts? Or 0, 6 and 0, 3, so that should be 0, comma 9, right? Okay, there's another point. Any other ideas? Or maybe that's enough. Because you figure when you add up two lines, you're going to get another one. Another line. So let's see if that worked. And we just highlight this to see if you went okay. Okay. So, Josh, there you go. You pegged one here. But what's wrong with this one? What's wrong with that intersection? Why is that on the, not in the addition, but Josh's is? What happened when we looked at intercepts? This is the intersection, and these are the intercepts, right? What do the intercepts have in common with point B?
Are we talking about the y?
3, 6, 9. So what do they all have in common? What all points have in common? Okay. Something else. Something more obvious. You got real tricky up there.
They're all on the y-axis.
They're on the y-axis, which means x equals 0. They're all the same 0. They all the same x. So now let's go back to your point. What do these two have in common? The points of the intersection, what do they have in common? Okay, that's where the two cross. But what do the coordinates have in common?
We have x is 1.
And y is 5. So what are you adding up? If you added up 0, 3 and 0, 6 to make 0, 9, what should you add up with these 2 points? They're both on the same, that point of intersection is the same thing. Should I add up the x's or the y's to add up the function? The y's. So where should it go?
0, 12.
No. Point A again.
0, 9.
0,
We already
9.
have a 0, 9.
No, yeah, we already got 0, 9.
No, but if you go up for another one, it should be 0, 12. And that's
It's going to keep the same x of 1. That's where they crossed.
1, 9.
But what's going to be the y?
1, 12.
If this was 1, 5 on the blue and it's 1, 5 on the red, 1, 10.
Oh, yeah. Why? Because it's 5. That's good for languages. Sorry.
1, 10, and then you're on the curve, right? Okay, so this we took a long time on, but this is the key idea of what you're doing when you're adding, subtracting, multiplying functions. You're doing it to the y values. Keeping the same x value, doing the same thing to the y values. Okay, so now it should be better with the subtraction. Now we're going to turn off the addition. We're going to turn on the subtraction. Here's the subtraction. Y. Give me 1 point. Why does that subtraction work out?
1, 0. I think 0, 1. No, yeah.
What happened with the intercepts?
They shifted over 1, 2, 3.
I'm thinking about the y-intercepts. Yeah, so if this is f of x minus g of x,
Oh, 5.
it's the y coordinate 3 minus the 6, and you're down at negative 3.
Is it okay that you can't see the coordinates?
You can come closer. You can stand here.
So should I not, like, get the people? I
Or
don't
you
know what
can get move between the two.
Wait, I don't get my, like, what Maggie's position is.
She's taping you live,
So
so you
I
can see your question more, okay? It's not a live feed, no.
I
Okay.
came to.
All right. Now let's go on to, so that was subtraction. Now we're going to go to, what if we subtract the other way? This was f of x minus g of x created this. What's going to happen if we do g of x minus f of x?
It'll look like that.
So you're predicting coming down. What's the slope of this? Positive or negative?
It'll be a negative.
Negative slope. And what is f of x minus g of x compared to g of x minus f of x? What happens when you switch the subtraction around? What do you do? Switching the
Making it
whole thing
negative.
goes negative. What happens when you negatize a function on the outside of the function notation?
It flips
Over.
y-axis.
Over the x-axis. So let's see if this flips over the x-axis. That was definitely a flip over the x-axis, right?
Wait, isn't this the
It's a big change in slope. No, this is the x-axis. And we just took this and flipped it over to the x-axis. Okay? Because you did the composition, not composition, the combination, the subtraction of functions in reverse order. So be careful how you subtract functions. Okay, we're going to turn those off now. Now, what happens when you multiply two functions?
It stretches. Just kidding.
Will it stretch?
It will.
Again, remember, what are you doing to the y coordinates? No. That's stretching and shrinking a single function. This is now combinations of two functions. And we're about to multiply them together here.
It'll increase the slope.
Will it have the same slope?
No.
Let's just take a look. I think it's going to freak you out.
Oh man.
What is this?
Two straight lines.
Is it?
No, they're not straight.
They're not straight. Time to change your window.
Oh my gosh.
What happened?
Parabola. Oh my gosh.
It's a parabola because what happens when you multiply two linear functions
Oh, we
together?
got an x squared.
The x squared. And notice the negative x squared is going to make it come down. Now tell me one of the other things. Where are the intercepts on the parabola? Where's the parabola across the x-axis?
0, 6, 0, and negative 0.5.
And where else? What else crosses it?
Good lines.
Lines. That's why we like it in this factored form.
Oh, that's it.
Because where the lines make 0, the product will make 0, right? How about the peak? Where's the peak?
28.
So it's not where these two cross, is it?
27.5.
27.5. But how do you find out where this peaks?
Max. Do max.
Is that the maximum if you use max on your calculator? How about if you're just looking at this picture? What are two things that can help you figure it out?
2.25. You can make
Where's the axis of symmetry about? Someone show me with your arms. Show me with your arms. Right around there. Okay. And where did that cut the x-axis? Compared to what? There you go, halfway between those two.
Oh.
So that's out of the trick to quickly coming up with the x squared of the vertex. Okay, that's multiplying two functions. What about dividing them? Is it going to be a line?
No.
Anything funny going to happen?
They're dividing in x. Oh. It's
And you're dividing by x, and x is underneath. What happens at 6? It can't be 6.
Nope.
It can't be 6. Sure enough, it can't be 6.
Oh.
And that's
Vertical
how-
asymptote.
What if we just divide the other way, though? Same thing?
Good. What?
No, much different function if you divide the other way. All right? Now, another concept now, this is really different now. And this is the composition of two functions. N is f of g of x. That's when you put the output of one function into the other. And for a picture, we get another line again. This is very hard to see visually because you're not keeping the same x's for each. You're taking the output of one function as the input for the next. So unlike all these other ones, where you could keep 2 points with the same x and just add, subtract, multiply, divide their y's. Now, the composition of functions is much different. So, we're going to shift gears now and go back to our, here. Now we're going to actually do this algebraically. So here goes. Algebraically, I'm going to do the first one, then I'm going to want volunteers on the next, okay? Algebraically, to add these two up, to do f plus g of x, which is also known as, I usually do this, f of x plus g of x. F of x plus g of x, I just replace the f of x with 2x plus 3, and the g of x with 6 minus x. And so I add up the x's, and add up the y's, or add up the constant terms, and I get x plus 9. And sure, that was our graph before, x plus 9, y intercept was 9. So that's the combining two functions by addition. Okay? You got it?
Yeah.
All right. Volunteer. Go for it. Difference.
4 minutes left.
That's fine. Minus. That's 3. There you go. Okay. All right. We just do some surgical erasing here, and we can take that out. Yours is a little longer because you started.
Yeah. Are we going to be able to watch this?
Yes. Not like that.
Yeah. Ow! Ow!
Easy. Now I can use that with Mr. R and give you both attention. Okay? There you go. 9x, negative 12, 2x squared plus 9x.
Good.
All right, and then the dividing, which could be the trickiest. I'm just kidding. That's the trickiest, people. Come on. Stop freaking out. F of x over g of x is 2x plus 3 over 6 minus x, and you're done. Okay?
Can't do anything?
But now you can see, well, when we start graphing it, we're going to have a whole section on graphing rational functions like this. So I was saying, you got a problem with 6 there. Because you have to reduce by 0 and that was the vertical asymptote, right? But there's also horizontal asymptote, which is going to be a 2 over negative 1. Okay, now to wrap up composition of functions. This is perhaps the doozer amongst doozers. How do you do f of g of x? I'm going to do the first one. I'll get a volunteer for the next one. F of 6 minus x. We replace the g of x with 6 minus x. And now, twice 6 minus x plus 3. Everything that was x before in f of x now becomes 6 minus x. And then you distribute 12 minus 2x plus 3. So we get 15 minus 2x. There's our f of g of x. Okay? So now you need a volunteer for g of f of x. And let me just, do you remember what the two functions are?
No.
I'm sorry. That, I thought I could get lucky and just paste what I had pasted before. So what we do is pause for, set, go. Okay, we're back.
Okay. Back. So that's g of 2x plus 3, which equals 6 minus. Oops. Wait, hold on. Okay, 6 minus 2x minus 3 equals minus 2x minus plus 3.
Minus 2x plus 3. That's
right?
great. Okay, and what I'll do is I'll paste that diagram on here so we got pictures of everything we did to check it. If there's any mistakes, I'll fix it. Okay? What do you say?
Blacked out!
Okay.
Oh, I didn't know.
Stop the tape. Oh, you know what? I forgot to record that.
Blanked out?
No, you recorded. That's
No,
fine.
look, it was recording. No, we'll do
Oh, right. I gotta go like this.